Hi, now I am going to explain about data types which is available in the system Verilog. So what are all the data types we have in Verilog? All are available in the system Verilog. So generally we can classify the data types as structural and behavioral. So structural data types are wire and ridge. So it is creating a structure. Wire is used for creating the interface between the components, and ridge is used to hold the value. The default state of ridge is X and the default state of wire is Z. Then behavioral data types are integer, real, time and logic. Integer can capable to store 32-bit and real can capable to store 64-bit. And to store the real numbers, you have to declare a variable as real, and time is used to store 64-bit, and with the help of $time we can able to store the current simulation time. Here all are 4-state data types. 4-state in the sense 0, 1, X, Z. Okay. The only data type introduced in the system Verilog is with the 4-state is logic. Okay. So in Verilog, when you follow data flow modeling, okay, we need to declare the output as wire. Output should be a wire. When you use a behavior modeling, the output should be a ridge. Okay. To avoid this confusion, okay, we have a data type logic. So we can, if you declare a variable as a logic, that may be used as a ridge, that may be used as a wire. Okay. The another use of this logic is the DUT. Inside the DUT, here, so inside the DUT it is implemented in Verilog. Okay, all are 4-state data types. In system Verilog, okay, all are 2-state data types. Okay. The logic is only one data type as a 4-state. So inside the interface, okay, there is an interface class in system Verilog. Inside the interface, we are declaring all the input and output as logic, so that it can able to support for the DUT and as well as for the test bench environment. Okay. Then 2-state data types. So apart from the logic, okay, other newly introduced data types are 2 states. Why we need 2 states means to improve the performance and memory usage. To reduce the memory usage, we need 2-state data types. These are the 2-state data types: bit, byte, int, long int and short int. So bit is a single bit, byte is a 7-bit, int is a 32-bit, and short int it is a 16-bit, and long int is a 64-bit. That's the difference between int and integer. We have integer data type and as well as int data type. The difference is integer is a 4-state data type, int is a 2-state data type. Okay. Only 0 and 1 it can hold. Then bit is a unsigned data type, and the remaining byte, short int and long int are signed data type. Unsigned means it can hold only the positive values. Signed means it can hold positive and as well as negative values. So this is the way you need to represent int, integer. This is a variable name. If you declare this integer as int, so this can hold 32-bit. It is a signed variable. Byte 8-bit. So this 8-bit variable can hold 8 bits. That is 1 byte. Default it is a signed variable. If I want to use this data type as unsigned, I need to write int unsigned keyword you need to use. Int unsigned that variable name. Now this integer is a 32-bit and unsigned variable. The same way byte, unsigned 8-bit. So now this 8-bit is a unsigned byte. That means it can hold only positive values. The same way you can also represent unsigned data type. Here bit is a defaultly unsigned one. So I want to use this as signed, means I can declare with the keyword signed. Bit signed 7 is to 0 A. Like that I can able to convert this as a signed data type. Then data type classification. So generally the data type can be classified into based on the states. We can classify it as a 2-state data type and 4-state data type. 2-state data types are bit, byte, int, short int, long int, byte, and 4-state data types are rich, where you can add logic, integer, time. Then based on the signed and unsigned, we can classify two types: and short int, long int, integer, byte, or signed data types. And unsigned data types are single bits. Okay, bit is a single bit, ridge is a single bit, logic is a single bit, and time you have to represent only in positive, right? So these are all unsigned data types. If you see what are all the data types we used in Verilog, all are 4-state data types. Okay, only logic data type is introduced in system Verilog as a 4-state data type. Remaining all are 2-state data types. The next data type is string. A string data type is a variable size. It is dynamically allocate array of bytes. So each character need a byte. Okay, the string is a data type, so it will dynamically allocate a memory based on the length of the string. Then you have a user-defined data type. Typedef is a keyword used for user-defined data type. I can create my own data type here with the help of typedef keyword. Typedef int integer b. So now integer b is going to act as a data type. That is nothing but an int data type. Let's see example. Okay. Now the model name is data type. So I used typedef keyword to create a user-defined data type int mode. So now mode is going to act as a data type for type int. I declared a variable as mode, b variable as mode, nothing but a int. Okay. A value is 50 and assigned b value as 40. Real c equal to a plus b. Then string is a data type. I declared a s variable as a string, and I am storing the character string here. System Verilog. The string should be mentioned within the double quote. Then within the initial begin end, I am just displaying the values of a, b, and real c and string. To display that, here I am going to display with the decimal format %d. Here I am going to display in the fractional format with the help of floating, you can say %f, and I'm going to display in the form of string, so I'm using %s. See here, a value 50, b value 40, and c is displaying floating, and s is nothing but a system value. So this value I'm giving between this percentage and the base specifier, as here I mentioned 0. Okay, the meaning is that I'm giving no space between the value and the variable a equal to, without space I am displaying the value 50. If I remove this, so default it is a integer, right? So at the LSB position I will get the value. See here, there is a huge space between this equal to and the value. So if I give 5, it will give a 5 character space. See here, some space is there. Okay. To avoid this space, I am giving this 0 here. Then this string data type, I already told, it is dynamically create or increase the size of array based on the character length. If the character length, the string length is n, it will create a memory array size, okay, from 0 to n minus 1. Okay. Each index from 0th index, first character will be located, and first index, second character will be located. Okay. So in this way it will create a array. So in this example, st1 and st2 are the strings. Okay, I declared as a string. st1 is nothing but null. There is nothing within this double quote. st2 is a ABC, and here st1 equal to, I am doing concatenation of st1 and st2. So I will get st2 value abc1. Okay, st1 is nothing, so abc is assigned to st1, and in st2 I am assigning e and t in the location 0 and 1. Clearly st2 is a, b, c. A is located in first index, b is there in 1, that is a is 0, b is 1, and c is 2. When I give st of 0 is 1, at 0th location e will be placed. Okay, instead of a, e is there, and t is located in the first position. Okay, now it is becoming as etc. Then this string supports relation operators like equality and non-equality, less than or equal to, greater than equal to, and concatenation and replication. So all these things we can perform with the string. For example, if you give like this a less than b, it's a true, because as per the alphabet order b comes after a only, and it will check based on the ASCII value. By means of dot operator, can able to access the special methods which is available with the string data type. Okay. These are all the methods available. Methods in the sense functions. Length, it is used to give the number of characters which is available in the given string. Okay. And put c is used to put the character, and get c is to get the character. Then to upper, it will convert into uppercase. To lower, it will convert the given string into lowercase. And compare, it is used to compare the two strings which is mentioned inside the bracket, and before this we are mentioning the string, it will compare both these. And then I compare, ignore case and can do comparison. Then substring, it is used to divide a particular, take a particular portion of the string. Let's we discuss this operators and methods with these examples. Okay. In this model TB, string first name and last name are declared as string. First name holds VLSI and last name holds design. Here I'm going to do these operations like equality. I'm checking if first name equal to last name. If it here it's not going to match, so I won't get this display. Okay, here I am checking for inequality, so it is satisfying, so I will get the display of this one. First name VLSI is not equal to last name design. Okay, then this one it will check VLSI less than design. First it will take the first 0th position of the word and it will compare. Okay, first V and this is D, so it is not satisfying. Okay, so this one first name is greater than last name, so first letter it is V and it is D, so it is true. V ASCII value of V is greater than D. Okay, it will check for first one. If it is matched, and then it will check for the second position. Okay. Then it is satisfied, you will get the output of this one. Then here I am doing concatenation, first name, then there is a space within this double quote and the last name, and then replication. 3 times I want to display the first name, nothing but a VLSI. Okay. Then this is to access the particular portion of particular character. Okay. Here if I mention first name of 2, this is first name, this is the position 0th position, and L is the first position and S is the second position, and I give like this, I am getting a character capital S. For last name this is 0 and this is 1 and this is 2, I am getting small s as output. See here VLSI is not equal to design and VLSI is greater than design. This is for concatenation, I am getting VLSI space design, and VLSI is printing 3 times due to the repetition operator, and here I am getting capital S, which is present in the third position, and here I am getting small s, which is present in this third position in the last name. The next example, this is to understand the methods of the string. Here string str is a variable, it is declared as a string, and I am holding put this value inside this string str, hello world. Okay. So here I created a temp that is also a string data type. Here I display the length of the string. Okay. String length, I am displaying decimal. Here I am using the length method, str.length. Okay, this method will return how many characters are there, 1 2 3 4 5, space also considered as a character, 6 7 8 9 10 11 12, so it will return 12 here. Then second, see here I am getting length as 12. Then next method, here before that I am copy the str to temp. Str is nothing but hello world, that I put in temp, and temp dot in the temp inside temp put c, using put c method. So this one tells where I need to put in the third position, what I need to put, that is D. Okay, what is there in the third position? Actually the given word is hello world, third position 0 1 2 3, third position is this L, in third position instead of this L I am going to put D. Okay, if I print I am getting HELDO world. Okay, Then get next is get C. Get C is used to take a particular character from the given location. So string dot get C2. So what is there in second position? This L. Okay, this L is printing here. Okay. And also I am printing the value with the help of percentage %d. I am printing the value of L. The ASCII value of L is 108. Then with the help of to lower, I am converting all the character to a lowercase. Actually, the given stored value, stored string H and W are in capital. So in the output, it is becoming lowercase. Then inside the temp, I am putting the same string which is there, the actual string str, hello world. I am doing compare between str and temp with the help of compare method. So both are same, right? So I won't get any values when both are same. If it is vary, I will get some value. Okay. So based on each character value, ASCII value, it will do comparison. Okay. Then if it is not matched, it will give the remaining values. Then I compare. Before this, inside the temp, I am putting hello world. Here H and W are in small letter. Here I am comparing str with temp. Okay. With the help of I compare. So I compare is a ignore case and do the comparison operation. So both are same. I am getting 0. Then substring string dot substring 4,8 I am giving. That means it will take from 4 to 8. This is the actual string. Okay. This 0, 1, 2, 3, 4. 4 is 0. So O space, that is 5, 6, 7, 8. So it will take the particular portion of the string with the help of substring method. It is displaying here. Okay, this one we are getting as an output. So these are the uses of string methods. Then next is enumeration data type. So enum data type is defined as a set of named values. For example, enum is a keyword. Okay. It is used to define a set of named values for colors. Color is a variable, so it can hold any one of these names along with its value. For example, defaultly red value is, this is in the first question, right? So this value is 0 and this is 1, 2, 3, 4, 5. You can also explicitly mention the value for that name. For example, in the next one, enum red equal to 0. If I mention like this, automatically green value become 1 and blue value is 4, means yellow value become 5. If I mention white as 10, white equal to 10 means black value is 11. Okay. Then here, now don't consider this type def. Here, PKT type. PKT type should contains any one of these, good and bad. Now with the help of type def, the type def is used to create a user defined data type. Now if I mention this one, this PKT type becoming a data type. So this data type can hold good or bad. Okay. So I am declaring a variable PKTA as a packet type. Now it is acting as a data type. So this PKTA may contain good or bad. So these are the methods associated with the enumeration data type. So first, it returns the value of first member in the list, and last it will return the last member in the list. Next, now we are taking a red means when I give color dot next, it will give green. So next of n, return the value of the next n member of the list. Okay, now currently I am in red. Okay, so if I give color dot next 2, so it will give blue. Then previous, it will give the previous color from the current position. Previous n, the same way it will return the value of previous nth member. And name, it returns the number of elements in the given list. How many numbers or number of elements are there, it will return the value. Then name returns the string representation of the given enumeration value. Here red, green, blue or the names. Okay, we'll see an example for this. Here in this example, enum data type is a module. Okay, within that I declared colors as a enum data type. Okay, so this color contain and named red, green, blue, yellow, white, black along with its value. Now within this initial block, for colors I am assigning colors dot first. Colors dot first, that will give red. Okay, it is assigned to this colors. Now colors is red, and inside the for loop it will run for 5 times from 0 to 5. I am going to display color dot name. Okay. So color dot name is the method used to give the name string. So it is red, which is stored here. Okay, it will give red first time. First iteration it will give red, and colors it is printed in percentage %d. It will return the corresponding value for that. This is 0, this is 1, this is 2, 3, 4, 5. And after this display, colors equal to color dot next. Color dot next is the function. It gives the next name which is available in the list. Green is assigned to color. So next iteration it is displaying green, and it is displaying the corresponding value of green. Then it will move to blue, and it will repeat up to black 5 times to blue. See here, red first, then green, 1, blue, 2, yellow, 3, white, 4, black is 5. So in this example, I created a enum data type, enum packet type. So this one I am type defing. I do type def. So now pkt type is becoming a data type. So with the help of pkt type, I am declaring the variable pkta and pktb. Okay, pkta contain good or bad. In the same way, pktb contain good or bad. Within the initial beginning, here I am assigning good to pkta and bad to pktb. And with the help of if condition, I am checking pkta equal to good or not. If it is good, I am getting this display. pkta is good. Else I am getting this display. Here pkta I as less good, so I will get this display. pkta is good. And pktb I am assigning bad. Okay, so bad is there, right? So it can only we can able to assign these two. Okay, other strings, other names we don't have here. So only you have to assign good or bad. And good containing the value 0 and bad containing the value 1. Here it checks pktb equal to good. No, it is assigned as bad, so it goes to else part and it is displaying pktb is bad packet. See here, PKD is good and PKDB is bad packet. Then, so this data type can be used to define the states in the finite state machines. So if you see in the finite state machine, we have current state and next state. So the current state and next state may be states in one of the state S0, S1, or S2. Okay. So those things we can mention inside the list, and it is declared as a. So this S0 and S1, S2 need to be 2-bit. So I use this one, logic 1:0. So if I mention logic 1:0, S0 contain a 2-bit, S1 also a 2-bit, and S2 also 2-bit. Values are 0, 1, 2. Okay. Then here I didn't mention any bit size. Okay. So default it is a int. If you want to mention explicitly the size of this variable, okay, you have to mention here. And structures. So this is the data type available in system Verilog, but we are not using this structural data type in developing the verification components or design, because struct is a data type. It is a static one. So within the struct, you can able to uh, declare multiple types of data types. Okay. So for example, my byte, it is a bit, and my data is the integer type. Pi is a real type. So multiple data types can be declared inside the struct. Okay. So this is the general syntax. Struct is a keyword. Within this curly bracket, we need to mention the data types, and this is the name of the structure. You can give any name here. To access the variable inside the struct, you have to do like this. My struct structure name dot my byte equal to, you can able to assign the values for that. If you want to assign whole thing, you can give like this: my struct equal to, within this core, single core, within this curly bracket you mention 0 is assigned for my byte, 99 is assigned for my data, and 3.14 is assigned for 5. Okay. So why we are not using this structural means, one thing, it is a static one. Okay, memory is created for all the data types. Okay, and we don't have the concept of polymorphism and inheritance in the structure. So we go for class based one. Okay. Then literals. So this one we already discussed. Okay. So on literal is a string. If you declare a variable as a string, so string should be represented within the double quote. And one more thing, this value, okay, within this percentage and this format specifier, between this, if you use 0, there is a no space between the variable and the value. If you give some value, if it is a fractional floating value, if you give 1, this is for round of value and this is for the fractional values. If you give 5, it will give a 5 character space in the display. And system Verilog allow easy specification of unsized literals value with help of this apostrophe. You can directly mention like this: tick 0, tick 1, tick x, tick capital X, tick small z or capital Z. You can use anything here. Okay. So here you no need to mention the size of the bit to represent and the base specifier. If you give like this, in this example, reach the 23 is to 0a equal to tick z. If you mention like this, variable a, all locations, that is whole 24 location, it is filled with Z. Okay. Next is operators that we will discuss later.